In this nugget, you and I are going to take a look at how we can use Network Time Protocol, NTP, to get additional information out of network devices. One of the benefits of a company taking things like Network Time Protocol for granted is that they don't continue to update it or keep track of it. And behind the scenes, we're using Network Time Protocol to synchronize time across most of our network devices. Let's take this Windows server, for example. It's got NTP services running. And then clients who are part of that domain are automatically using that Windows service, NTP, to synchronize their own clocks. And on the internet, there's atomic clocks available that are considered to be very, very accurate. And many times we'll have devices inside of our network synchronize with those external clocks as well. So if router 1 is synchronizing with the atomic clock, and then the internal server is synchronizing with router 1, and then the clients are synchronizing with the internal server, all the time on these various devices can be very close. And the reason that you and I might care about that is because log files, if they have accurate date and timestamps, that's helpful to find out what is happening in the network. It's also important in a Kerberos environment such as Active Directory that time be accurate so the tickets that are being granted continue to work correctly. So I'll put AD here as another reason why we would want accurate time being used. We also might have digital certificates in our environment. And if the time is way off on one computer and it receives a digital certificate that's supposed to be valid between, for example, 2016 and 2019, but the computer thinks it's 2012, the computer may consider that certificate not valid because the computer's clock is wrong. Regarding enumeration and learning details about the network, check this out. If someone has an older Network Time Protocol server in their network, queries can be made to that NTP server by an attacker or anyone. The NTP server could cough up information about the clients that are currently using that NTP server. So if we want to know the IP addresses in use on a network, and we can make an NTP query, it's a very easy way to get those IP addresses if the NTP server is using an older version and still supports those types of requests. And the client list could look something like, for example, 10.1.0.50 and 10.3.9.40. And if we're using, for example, a 24-bit mask, we're now identifying the various subnets that are also available based on the IP addresses on those networks. So it can help us map out the network topology just by talking to the NTP server. And there's lots of tools, both native and third-party, that we can use to learn about and discover information via NTP requests. It's also important to know what port is involved with NTP. And that's because if we're doing a network scan and we see UDP, port 123, sounds like a Michael Jackson song, UDP 123. Or maybe that was Jackson 5. And the reason that's important for you and I to know is that if we're doing a scan of the network and we see UDP port 123 open, that's a possible candidate for further enumeration via NTP requests to that device. And one of the tools that we might want to use on this Kali box is called NTP date. And to install, we'd use apt-get, apt-get, space, install, space, NTP date, and press enter. And that will go through and download and install the NTP date application. Before we do NTP date, let's go ahead and also launch Wireshark. So we'll go ahead and go to a new terminal, type in Wireshark, and press enter, and start the capture on Ethernet 0 so we can see the play-by-play. That'll help us to confirm the ports that are being used by NTP. So we'll go ahead and we'll press enter. Also here on Kali Linux, there's some NTP-based commands that are included in the distribution, including a command called NTP-DC. So we'll type that in at the command line and press enter. And that puts us into interactive mode. We can type in help to get help with that command. And depending on the type of NTP server that we're working with, some of these commands may or may not work. For example, monlist is fantastic for an older NTP server that supports that command. Because if the server is going to cough up that information, it would communicate to us the IP addresses of the current clients that NTP server is supporting. And we could try other commands here. We could also try different NTP servers. And if we find an older NTP server that is supporting that request, that's a jackpot because of the IP addresses it can feed back to us. Now let's exit out of this tool, NTP-DC. And there are other tools like Nmap that can also be used with scripts to enumerate NTP-based information. So for example, if we type in nmap space -su, we're going to do a UDP scan, space dash lowercase p, and then uppercase U:123. And that's the protocol that we're using with Network Time Protocol, UDP port 123. And then we'll use one of the many scripts that comes as part of Nmap. And to use that, we're going to use -- script equal NTP -monlist. And then we'll put in our target of 192.168.1.212. So if we launch this, because the server is not coughing up that information based on the monlist command, we're not going to get a list of the current clients. However, we can verify that UDP port 123 is open. And if we use the monlist option, either in Nmap or in the NTP command, and we connect it to a server that was vulnerable to that or willing to share that information with us, here's an example of the type of information we could gather, including IP addresses, both IPv4 and IPv6 in this output, of clients that are using that NTP server. Again, that would be very helpful if we're enumerating and discovering additional information about the network. In this example, we're doing the enumeration via NTP services. And I almost forgot, we've got the packet capture running in the background with Wireshark. Let's open that up. I've got over 7,000 packets. We'll stop that, and let's do a display filter by typing in udp.port = 123 and press enter. And that'll show us just packets that involve UDP port 123 as the source or destination. So this packet at the top, which is sourced from .109, that's our Kali Linux box going to 212. We look at the details down here. It's using UDP, and the port number is 123. And that's a network time protocol request, and the next packet is from the server back to the client with a response. Down here at the bottom, packet 6263. We're making a request, and right here the request mode is mon get list. And it's that request right there that if we'd reached an NTP server that was older and still supporting that, would have fed us back the information regarding clients that are currently connecting to and using that NTP service. In this nugget, you and I have taken a look at the concept and a couple of tools to get enumeration and data based on network time protocol. I hope this has been informative for you, and I'd like to thank you for viewing.